Right, we're recording obviously, and we're beginning our discussion on the modified Euler's method, but most importantly, we begin with an example after we had a couple of examples in the past couple of days. Use the modified Euler's method with delta t equals 1 and with 2 corrections, 1 correction, 1 recorrection per step to find x of 1 and y of 1 for the initial value problem. Right, given dx dt equals t plus x plus y, at x at 0 is 1, dy dt is y minus x, and y at 0 is 0. Y at 0 is, okay, it must be 0. Must be 0 here, so you can see I wrote a 1 here. Right, it must be a big 0. Okay, so we have to pick the eraser from here now, because I wrote a 1 here. It must be 0. It's fine. Okay, so let's continue. Now we pretty much are well sorted. Right, the solution is as follows. I was beginning the solution yesterday, and we are beginning it right now. We start by say actually the solution as follows, and we say by using the modified Euler's method. Write dx dt is a function f that is a function of x, y, and t. Right, x, y, and t. X of t is x of 0. Dy dt is g xy t and y at t0 is y0. Like so. So with that in mind, we begin as follows, as we did over the past couple of days, like yesterday. We first deal with the predictor, like slightly different notation. Instead of using the superscript, we're using the subscript P, H, F, T, Y, T plus 1, P, Y sub T, H. So in other words, this one has two differential equations. Because there are two differential equations, then we're gonna have two equations for the predictor. G here, xt, yt, together with t like so. We proceed also and realize that we're gonna have the corrector as well. And the corrector is t, like that. And it is xt plus h over 2 f of xt yt t together with f of xt plus 1 t, rather p. T plus 1 p. T plus 1. Y. All right, so just to write a bit clearly here. Right, so we have t plus 1, then we have p subscript. And then here we have subscript t plus 1 c for the corrector. And then we have yt. So obviously we have two equations for the corrector. And then we have here xt, yt, t plus g, x, t plus 1 p, y, t plus 1 p. Right, so we have the two equations, both the predictor and the corrector is stated before, but this problem is having two differential equations, and hence we have two predictor and corrector equations respectively. Okay. Now we here have been given the initial value problem, given the IVP. Okay, let me write like clearly, like given the IVP as follows: dx dt equals t plus x plus y. And this is a function of x, y, and t. X of 0 is 1. The second equation given in the question is y minus x. This is g, which is x, y, t, and we have that y at 0 is 0. Okay, this is the given initial value problem, but now we need to deal with the predictor here. So the predictor at t equals 0. T0, for example, if you look at the x0, but also at the y0 as well, and then you have that, for example, t1. T1 is 1 because delta t is 1. So this delta t is like h. So if h is 1, then t1 is 1 because you just add the h to the 0 to get t1. So this is just another language for our standard h symbol, so that they use the delta t in this question, so that now x1 predictor is given by x0 plus delta t in the notation of this, which is the usual h, but is delta t here, x0, y0, because the question was using delta t in this exam. So x0 here we can see is 1 plus the delta t, the h is 1 also with the f. Now the f of these is what? We called f the sum of everything. So we're going to add everything. We're going to add x0, y0, t0. And now t0 is 0. So, and then y0. What is y0? Right, we saw that indeed t0. What is t0? T0 is also 0. But now what is y0? Okay. Right, look at this very, very carefully. Right. There's something I need to just check quickly here. If this is exactly the case, y0 is that, and you have x0, you have y0, and y0 is exactly 0. Right, so y0 here is exactly 1, but x0 is exactly that. Okay. Where am I? Where am I? Okay, just 1 second. There's something I need to just verify here quickly if that is the case, because, okay, obviously we understand that this is the given problem as it is, and we have y0 is 0 and x0 is 1. The predictor is given exactly that way. I need to verify, but my point is, first things first, let me write as follows so I can just check what's happening here. Okay, but now what is key first? Let me first write this step, then I'm going to do this on the next page. Right, so right, so this, okay, so this is exactly x0. Okay, that's fine. Let's write it as x0 plus, because it's something I just need to check here. Right, so obviously, according to this of the first differential equation, where we have the f, so f itself is defined as the sum of all these. So it's first t0 plus x0 plus y0. So let's continue. So that you have x1 predictor. Right, so which means x1 predictor. Right, we've already seen that it is exactly x of 0, which is okay. Delta t f of the summation. Let me just put the sum here. I want us to do the correct substitution of these things here. And then we have x0, y0 together with t0. Or the other way around, you can switch them around and put the t0 here because the question had t0 first. Okay, it's okay that's this way, but I want us to analyze this very carefully. And now, what is x0? Right, x0 is clearly a 1 plus the delta t, we have seen that it is 1 as well. Right, what is x0? Aha, x0 is a 1. What I wanted to just to say. So x0 becomes 1 because this notation here, I think I might have mentioned it somewhere. Okay, right, because in this notation that according to the way we define it, xt0 is x0, so and then you have yt0 is y0. Obviously, what it means is that at this point, this is x0, which is 1, this is t0, which is 0. Okay, so, and then, so x0 is 1, and then now what is y0? We have seen that y0 is 0 and t0 is 0. All right, and therefore this is 1 plus 1, 2. Okay, it's perfect now. And then now you then have also the next one for the, because there are two equations for the predictor, x and y. So you have the y1, you're done with the x1, so which means the y1 predictor. Okay. Right, what is the y1 predictor? Is y0 plus delta t g x0 y0 t0. Okay, what is g? Need to just plug in the g. So g is actually this, is y minus x. So you can just plug it in here. So this is y0 delta t, and then it is y minus x, or in the language of this here, notation of this, it will be y0 minus x0. So we're asking the question, what is y0? Y0, according to this, obviously it's going to come exactly from here. So our y0, we can see clearly is actually a big 0. And t0 is 0. Y0 is this one. So is 0. The delta is 1. Y0 is 0 minus x0. We have seen, therefore, that x0 is 1. Okay, so it's okay. And then now if you deal with this, it's minus 1. All right. Okay, this has just been the predictor, and then the next thing we're going to do is the corrector. Right, the corrector has its own equations as well. They are one step because at the origin, we start from 0, we just add 1. We just add 1h. So like we add 1 delta t, so that this one is x0 plus delta t over 2. Okay, x0, y0 t0 plus f of x1 p y1 p t1, like this. So, which means that x1 corrector. Okay, what is x0? We saw that x0 is 1. X0 is 1, T0 is 0. Okay, but this delta T is 1. Okay, what is F of these things? F of these things, we add them up. So as we saw, it's going to be T0, X0, Y0. T0, X0, Y0. Is T0, X0, Y0. And then now, the F is the same thing. So it's going to be exactly T1 X1P plus Y1P for the predictor. Okay, let's just do some substitutions here. 1 plus 1/2. Okay, what is T0? Right, in both instances, T0 is a big 0 because it's the argument here in the, so it's T0 is 0 in there, it's T0 as well. So it's 0 in both instances, so it has to agree with each of the given pieces of information. And then we have seen that x0 itself is 1, y0 is 0. So what is T1? With T1, we just add 1 delta T to it, so it's 1. You add 1 to 0. You add 1h, like we were doing before, using the h notation. So what is x1 predictor? We got it. X1 predictor is 2. So X1 predictor is 2. What is Y1 predictor? Y1 predictor is a minus 1. Like so. X1 corrector. 1 plus 1/2. So what is this? 1, 2, 3. 3 plus 2. Right, so you have 3 plus 2. Okay, I need to just check if this is working very well. So which means Y1, Y0. Okay, what do we get here first? Okay, and I'll just check that. So this is 1, 2, 3, then 5 minus 1 is a 4. And it appears that this is half of these 2 plus 1, 3. Okay, which is T0, Y0, T0, X, yeah, T0 is 0. Yeah, T0 is 0. But X0 is 1. Okay, so thing is different. So we can see that T0 is this one, which is 0, but X0 is 1. T0 is 0, Y0 is 0. So it's very important to realize that T0 is 0, X0 is 1, Y0 is 0. Okay, so it's fine here. T1 is 1, the X1P is 2. And the Y1P is minus 1. All right, so yeah, I just continuously check this to make sure that we have no errors. So it means we just need to add this correctly here. So this is exactly 1 plus 1, which is exactly a 2. And then 2 plus 2 is a 4, minus 1, 3. Good. So this is actually 1 plus 1.5, which is 2.5. Okay, I expected this exactly, so that's correct. Right, so the next thing we're going to do now is the y corrector. So we continue with the corrector, but we're going to do the y part. So y1. So we do the corrector at one step ahead of h. So what is then the answer to this? So this one here is a right. Okay, I want to write a bit more steps here. So in writing a bit more steps, it helps to write down the formula exactly like I was recommending so that you do not forget the formulas that, right. So this is YT1 corrector is YT plus H over 2 G of XT YT T, which is XT plus 1 YT plus 1 Okay, now let's get from this Y1 correct. So the one here is going to occur, Y1 is going to occur when T is 0. And this gives us, can write as much as Y0, H over 2. Just writing the H, but you can use the delta T. Okay, we're going to use them interchangeably. All right, so now here we have the G. Okay, the G is in the question. So G is Y minus X. So it's going to be Y0 minus X0. It's Y minus X according to the question. G is that. And then now you come to the G here for the predictor part. But this G also must just be Y minus X, but using the predictor variables. So which means that it's going to be Y into T plus 1. Okay. I need to substitute this, the subscript. So is going to be like a y1. You can call it in terms of this. You can use the commas here. P like this. So it's y minus x, x1p. Just y minus x, because that is what G is. G is y minus x, because dy dt is y minus x, which we chose to be G. Okay. Now, let's see what we have. So we have exactly this part. All right. So now we just have to substitute everything into this to get the answer of the correctors. So which means y1. What is y0? We saw that y0 is 0. Delta h or delta t, which is h, is 1. Y0 is 0 in the question. X0 is 1. Y1 predictor. Y1 predictor is minus 1. X1 predictor. X1 predictor is 2. Okay. What answer are we getting here? So this one here is going to be minus, minus, and then this is going to be minus 2. And then, okay, works out correctly. That's what I expected. So this is exactly 1/2 minus 4, which is minus 2. Okay, correct. Now we do the recorrection part. So let's do the recorrection. So in doing the recorrection, what do we have? Right. We continue. Now, in doing the recorrection part, there are a couple of things, obviously, that we need to consider. So, which means that for the recorrection, you would have x1, which is exactly using the correct. Now, the first correct equations, just write the first correct equation for x, so that we work from there. And say, for example, xt1, correct, is equal to xt plus h over 2. Okay, can call delta t or h here. Xt ytt plus f of xt1 p yt1 and then t1. And you close like this. So we continue. So now, all right. For the recorrection part, for example, what would x1 be? x1 correct, is going to occur when t0, x0, hey, use delta, let's use delta t for the h, same thing, but the question was using delta t. So we understand, therefore, that this is x0, y0, and you have here, call it t0, plus you have here x1p, y1p, call this t1, like so. Okay, it's exactly the language we use. So let's just break this down a little bit so that we have some fine understanding of this. So the next thing here is to substitute the functions. This one is t0, x0 plus y0. This one of f is t plus x plus y. So we just take the t plus x plus y like this. Okay, let's substitute, which means x1c is x0. x0 is 1. Delta t is 1 out of 2. t0 is 0. x0 is 1. y0 is 0. t1 is a 1. Okay, now we come to the two important predictor variables. So the x1 predictor and the y1 predictor. Right, so we need to look at these carefully and see how best we can decipher these and analyze this. But you have here a couple of things. And we have obtained here the effect of the variables. Okay, just going to be, you have the effect of the variables. So now at this point, you need to look at the fact that this sum here, where did this sum actually come from? So the sum of the functions with the delta t out of 2 is actually the sum of the functions that we have. But most importantly, it means therefore you'd have the, okay, I want to take you back to something here. Right, okay, when do the recorrection, because this is 2.5. 2.5. So when you do the recorrection, when do the recorrection, let me just make it easier here. Okay, to make the recorrection easier is to use the following approach. So you're gonna say the x1 correct is x0. For x0 you put 1 because that's what it is. Then you have 1 over 2. Then you take this one that appeared before and you half it. You put it here. So you put a 2.5 here. Okay, if you don't want to put a 2.5 there, you put, because that came from the previous x1 step, or you can put here 1 plus 1.5. So that this becomes 1 plus 1.25. 2.25. Like this. Okay. Now, you just note that. Okay, the 1.5 came from here. Okay, so you can write. So in other words, what you need to do is to consider for the recorrection part, you take half of this here. Half of that plus the x0. Right, next, let's do the recorrection again for the y, please. So there's another recorrection. Okay, now, okay. Okay, I'm going to first write this one, this giant equation, t plus 1 c yt plus h out of 2 g xt yt t plus g xt plus 1 predictor yt plus 1 predictor. Okay, we continue. So for the recorrection part, as I said before, for the other variable, for the x variable, so this one is going to become exactly like the same approach. So it's going to be exactly y0 plus 1/2 right. So you look at this very carefully and think of this. Right. So the couple of ways to reason these out. What did you get for the YC? I'm going to revert to that. But now what is very important is you take half of the previous step. Right, you take half of the previous step. What did we get in the previous step? Okay, so before that, I want to first break it down. I think it's easier that way. Okay, y0. So this one is going to be, let's write delta H, delta T, it's okay. Right, I'm looking for an easier way to sort of expand this. Now, this is going to be delta T, it's okay. And then here, okay, because it's y1 here, so these are going to be 0, all of them. So the g, remember, g is y minus x, so it's going to be y0 minus x0. And then it's going to be plus, so even this one here is going to be y1 predictor minus x1 predictor. Y minus x, like this. So what is the answer to this? So what is the answer? Okay, let's analyze this. So you have y1c. Okay, now y0 here, this point, we know that is 0 from the question. Delta t is 1 out of 2. And then we have y0. Y0, we know very well it's 0, we saw. X0, we know very well that it's a 1. Okay. And then now we have, I want us to analyze the y1p, x1p. Okay, x1p, for instance, you're getting 2.25. Y1p is minus 1. Okay, let's analyze these and see what we're getting. So we actually have that y1p is minus 1. Okay, let's substitute that one. Right, we're getting a minus 1 here. X1p, 2.25. 2.25. Like this. Okay. Right, so let's analyze this with match quotient. Analyze this with match quotient. So what is the answer to this? So this is y1c 1/2. So this one is minus 4.25. And you take half of these. Okay, let me just use my calculator here to see what the answer is going to be. Right, so we have 0.5 for just half times 4.25. Okay, 0.5 times 4.25. 0.5 times 4.25. Right, so what we're then getting is minus 2.125, like so. Right, hence the conclusion is that. Right, hence we have that. Right, we have that x1, right, is actually the same as 2.25. Let me just check that. Yes, 2.25. And the y1 is minus 2.125. Like so. Okay, there are a couple of ways to do this, which obviously I'm going to explore at some point. To make sure that one understands that these can be largely simplified. The next question we shall look at today is how to solve the following exam question that came in November. Right, so this says, I'm going to call it an example. Right, so in this example, the question says use the fourth order. Okay, this I'm sure is very familiar. Okay, this was the first question. Right, use the fourth order. Right, fourth order Taylor. Right. Sometimes the tendency is to say fourth order Taylor method than fourth order Taylor's method, in which case these are very interchangeable with delta x equals exactly 0.1 to solve. This was exactly the very first question, so we're just reverting back to the notion of Taylor for the exam purpose to solve the differential equation. Right. Either this came from June 2020 or from the November 2023, one of those. I just need to check, but pretty much the same question. Okay. Right, no change there because these papers were the same, November 2023 and June 2020. Right, so then you have the dy dx is y squared. Y0 is 1 at x equals 0.1 and x equals 0.2. Okay, obviously we discussed the thing, what you call it, the Taylor, but now we just need to use it in this exam question. So there are formulas that I gave, and these formulas I want us to just apply them now to solve this problem. The formulas for the Taylor, but we mentioned that Taylor and Euler are related, but Euler is Taylor of order 1. So if you consider Taylor of order 1, you get Euler. But we understood that the Taylor method has a lot of its own advantages, is more general, etc., etc. Okay, so we are beginning to solve this problem now, but I want first to cite and indicate the formulas that are useful here to solve this. Okay, so I'm just going to cite the formulas from Taylor from the previous writing that from our previous discussion. So, okay, so in other words, okay, I'll just be with you now. I'm just going to cite the formulas that we have used in our previous discussion on Taylor, because those are exactly the formulas we're going to use here. So we're going to use them at 2 points, at 0.1 and 0.2. And right, Taylor method. I'll just be in 1 second. Right. Right. 0.1, Taylor method, finish over problem. Right, 275. All right, so we saw that. Okay, I'm just want to bring back those formulas. Okay, these formulas that we use for the higher order Taylor methods are 2 of them, and I want to bring them here. Doesn't really matter what you do. Okay, the variables, you can play around with them. Now, let's look at the solution to these. But first, I want to write down the formulas, and then we're going to use them. Right. So what do we do to solve these? Okay, what does Taylor state? I want to state the formula from a previous discussion because it's what we're going to use here. Taylor method of order n. Okay, I'm going to set it in terms of w, but we can change to the y's and things. Okay, so we said w0 is alpha, and then wi plus 1 is wi plus h tn ti wi for each I. 0, 1, up to n minus 1. So yeah, we are here. And then now we also have, we said where? Now the t, the nth derivative of t, tiwi, is actually the same as f of tiwi plus h over 2 f primed of tiwi plus h n minus 1 n factorial, okay? Like so, you divide here. And then now you have f n minus 1. And then you have tiwi. Okay. Now let's continue, please. Okay. So for a problem, how do we use these formulas? That is the discussion you need to have. First things first, what is the initial value of this problem here? Okay, let's check the problem again. So we have that y0 is 1 is the initial value problem. So you have we have okay. So we're gonna write. Okay, I'm gonna write the question dy dx. Excuse. Right, dy dx is y squared. That is the question. Then you have y0 is 1. Okay, I want to just use those formulas there at x equals 0 0.1. Right. Want to solve this at this. So we want to get the solutions at these two. So obviously we need h here, but our h is called delta x. They called it like that in the exam. It's not me who is changing the variable. So the tendency just to change sometimes h or delta x, but it's the same thing. Okay. Right. Now, for purpose of the solution, first we note down in a step-by-step manner because we write y0 is alpha. So all right, so there are many ways to write the notations, or I'm going to use whatever is comfortable, so you can play around with the notations as well. Right, so let's use the W's. So we're going to use, for example, W0. It's okay. So if this is 1, it means in our notation is W0 equals 1. Okay. Because that's how we discussed it last time, but yeah, it doesn't really matter. Okay, now the next thing is to get to say this is f. We called it f, and we're going to maintain that it is f. So it becomes f of the variables we have. Okay, so in other words, what variables do we have here? So obviously we need to look at these and analyze carefully. This is a function of how many variables? So y is a function of x. That is why it's y dx. So which means we can write x, y. Okay, we can even write y of x like so, because y depends on x. That's why differentiating y with respect to x. Okay, Now, with that said, it means that we have this can be written in the F notation. Okay, nothing strange there. And then now, what do we do? Okay, excuse this, I just pressed the button. Okay, what do we do now? We analyze, because it must be fourth order. Okay, because it's a question. So now use the fourth order Taylor polynomial. So if it is the fourth order Taylor method, we stop at what? Right, we stop at what? Right, okay, I will actually most certainly explain that now. Let's come to this. Because if it is fourth order, it means this is n is 4, because it's a Taylor method of order 4. In this question is order 4 in the exam, so this is 4, n is 4. Okay, if n is 4, then how many of these do we write? Just analyze that. So you have to stop at n minus 1, so you need to stop at h cubed. Okay, if you stop at h cubed, then you're going to stop at 4 minus 1, which means you're going to stop at 3. It means, therefore, you're going to stop at the third derivative. You're going to stop at the third derivative. So it means that we stop at one derivative less. Okay, so we need to prepare for ourselves. So we need to find the derivatives. So we're going to find f primed. Okay. So which is x, y, x. Okay, so now what is this? Right, oops, x here. Right, so, okay, dx. Okay, what is y? It's exactly this. The f is this, which is y squared. So what is the derivative of this? Is 2y by implicit differentiation dy dx. Okay, but we must, because it's fourth order, we must do 3 derivatives. Okay, so now we must do 2 more. So, okay. Okay, continue, please. F primed. So continue. Okay. Okay, we're continuing, please. I need to just copy the previous one. Okay, F primed is this. But yeah, we need to write it nicely. So because it's F primed of x, y, x, which is 2y dy dx. It is 2y. What is dy dx in this question? Y squared. Which means this one written nicely is 2y cubed. Okay. And then we must find all of them. So now we must find f double primed of this, because we need fourth order. So we must do 3 derivatives. Right, so which means to find the second derivative, we must differentiate the first one. So because the function of x, we put d dx. Okay, is x like this. d dx of 2y cubed. Okay, because this one is 2y cubed, and the derivative is 6y squared dy dx. So it's 6y squared. What is dy dx? Is y squared. Okay, we know that dy dx is y squared in the question. So, all right. So what is this? It is exactly 6 y to the fourth power.
Okay, my brother.
Mm-hmm.
I just want to know how much must I give you so that I can.
All right, so you continue. All right. Okay, continue, please. We're continuing. Okay, we need the third one. So we have that the second one is what? 6y to the fourth power. And then we need the third one. Like this. So which means we must find the derivative with respect to x of this. Which is d dx. 6y to the fourth. 24y cubed. Dy dx, please. Um, all right. Okay, we got this. The third derivative, okay, is exactly this one here. Okay, what is the next thing that we need to do here? Okay, so we found all the derivatives, and then we need to continue with our next step, the substitution step. So what do we do now? We write the Tn formula. For Taylor, okay, we're going to use the Wi notation. So because that's what we used last time, it's in the textbook, prescribed textbook. So you have this plus h over 2 if these ti plus, okay, so let's just write more terms here. So what is the next one? Right, the next term is going to be, because if it's h here, the next one is h squared. F, same degree, 2 TIWI divided by, okay, yeah, I mean, the reason is exactly the formula. It's nothing bizarre that we're doing here. It's exactly this, but we're just writing more terms. So if you have FTI, then the next one is H over 2 that. Then obviously from the general term, then we can write more terms. Like, what is the term after H over 2? It's going to be H squared. Okay? Because now if it's 1 here, so if it's H squared, then is 2, second derivative. But now we divide by the n. So what does it mean? So if it's H2, then it means like it's 3 minus 1, so it's 3 factorial. That's the point I'm raising. So this one is going to be 3 factorial. So if it's 1 here, it's 2. Okay, this is 2 factorial, but 2 factorial is just 2. Right. But now we must write one more of these. Squeeze it here. And write H cubed F3 TIWI. Okay, so 4 factorial. Okay, because if it's 2, it's 3. If it's 3, it's 4. Okay, so we're done. Because it's the fourth order. Fourth order, you stop at 3. Okay. But the next thing is to do the substitutions here in terms of what each of these things is exactly. So, oh, yeah. Okay, what is each of these? Let's analyze these. So now we're going to have TIWI. Okay, what is FTIWI? So FTIWI is, the WI is like the Y. Okay, like YI. We even use YI, but yeah, we chose WI. So what is the question here? We know that, yeah, in terms of the notation, F is this. So FTIWI, what do you call it? XI. What have we called it? TI is the same thing, but let's just call it XI for convenience. Okay, because it's X is here. It's X is everywhere, so please let me just call it XI. It's convenient that way. Wherever these two, just put X. Okay. Wherever these two, put X. Doesn't matter. We can put T, but your it's more accurate for this question because this question uses X. But for the Y, okay, this is a prescribed textbook's way of doing things, but you can change the W's, you can use Y's, YI. Okay, but somehow the prescribed textbook uses this. Okay, so you have that. Now, okay, I wanted to say then here is XI, like this. Okay, now, what is this? Okay, the FXI YR is Y squared. It is Y squared. So, which means it's just going to be only the Y squared, so it's going to be WI squared. Okay. Like so. Next. Now we substitute this one. H over 2. So this one here, because it's a first, what is the first derivative of this? Okay. Okay, so F primed. Okay, so yeah. Okay, F primed is 2y cubed. So it's 2y cubed, so it's going to be 2wi cubed. Okay, the y is like w. You can even use yi, but yeah, the textbook uses wi, so I'm just maintaining that. Right, so plus h squared out of 3 factorial. Okay, even the textbook, the question uses delta x. Yeah, I can change that. Okay, that's fine. All right, what do we have here? Same thing. What is W? What is F double primed? Check. F double primed is 6y to the 4th power. F double primed is 6y to the 4th power. Okay. 6y to the 4th power. This one. 6y is like wi to the 4th power. Plus h cubed over 4 factorial. What is the third derivative? F triple primed is this. So I not write it. Okay. Can simplify this one because we don't want the derivatives to appear there. Okay, the dy dx we already know is y squared. So okay, so this one is 24. Okay. Okay, so it's 24y what? Y to the 5th power, because that's what we get here. So 24y to the 5th power, which means it's 24 wi to the 5th power. Like this. Okay, now this can be written in a couple of, okay, now there's something I need to modify here. Because obviously we're dealing with the 4th order. We can already, because we've already minimized the length of this, normally it goes up to infinity. Obviously it has more terms, but we are dealing with the 4th order. Okay, so already we're stopping at 3, meaning it's 4th order. Just at 3 because it stops at 1 less than the order, 1 less than 4. Okay, now, okay, we have this. I'm trying to do this a bit from first principles here. Right. Now we have this. Now, if we have this, what do we do with this? We just group things together and so on and so forth. Okay. So we have this. So what is all this here? Okay. What is all this here? Okay, we can leave it like that, but is there any factorization we can do? We always check. Right, not really much of a factorization here. This is just compact, except that we can just make these delta x out of 2. Wherever there is h, you can just put delta x, but doesn't make much of a difference. So, which is, anyway, okay, can simplify these numbers here. Okay, right, I had not really solved this problem myself, so I'm just trying to be very careful to just get the correct answer. So 2 divides here, so you can use delta x, wi cubed. So here, this one is 6, it cancels out. Wow, awesome thing. But is delta x in the question? They put delta x. You square that. This is wi to the 4th power because 3 factorial is 6. So that cancels out. Okay, we continue, please. We continue. Okay, now, even this one, because 4 factorial is 24, so it cancels out. Awesome, awesome, nice question. It simplifies beautifully so that we have delta x cubed. right? And then you have WI5, like this. So let's continue. Right. Now, with this, what do we do with this? We substitute it into the formula. What formula do we substitute these into? Into the difference equation. Now, using the difference equation associated with Taylor, right, using the difference equation. Okay, there are many difference equations. All those things. Now using the difference equation, yeah, associated with Taylor, because each of those approximation methods has difference equation, the difference equation associated with Taylor, right? Right, associated with Taylor. With Taylor's method. All right, we continue as follows. Right. Okay, now let's substitute. What is the difference equation? So we said Wi plus 1 is the same as Wi plus H. That is the formula that is in the textbook, but that's what I used last time. But I said you can change these here. So this is XI. You can use the Y in the ways of the W's. You can use Y's because this question has Y's. But this textbook uses the W's. Right. For each R equals 0, 1 up to n minus 1. Okay, so this is the formula for Taylor, but we must just plug in the correct T there that we just got. So which means that now what are we going to do here? We're going to plug in everything. So Wi plus 1 is Wi plus H. Okay, we're going to plug in the long thing, this one. So is Wi squared plus delta x Wi cubed plus delta x Wi to the fourth power Wi to the fourth power. So continue. Now, okay, I hope is delta x W cubed? Is it what it is? Delta x W cubed, then delta x squared Wi to the fourth power. Yeah. And then what else? And then delta x cubed Wi to the fifth power. Now, this is exactly what we have here. We have this exactly. Um, so okay, let's do this. Now here we can do in many ways. Okay, this is pretty much the answer we have. But all right, let's continue, please. If we have this, okay, we need to just simplify this. The next step is to substitute the delta x and just be left with, doesn't matter what you do here. Okay, we just want to get a nice difference equation. So, okay, I just kept this as h, but you can still put delta x here. And then in this question, it is 0.1. So just to get something, a difference equation that's just nicer to use, you just substitute the delta x, like you put 0.1 here. Then you have the wi squared. Substitute only the delta x throughout. Wi cubed, 0.1 cubed, 0.1. No. You squared this one. Let's see. Okay, so this one is squared, and then this 0.1 cubed, and then this one is squared. Wi to the fourth power, and then this one is cubed. 5. Oh, yes. Now we have this. We have this exactly. And what is the meaning of all this? What is the meaning of everything here that we have? Okay, let's move to the next page. So which means that Wi plus 1. Okay, we're going to just finish this question, please. It's Wi plus 0.1. And then what is it? You have these things here. It's weird. Powers keep rising. Okay, so it's Wi squared. Zero 0.1 Wi cubed. And then 0.1 squared Wi to the fourth power. Plus, what is the next thing? Okay, 0.1 cubed Wi to the fifth power. 0.1 cubed Wi to the fifth power. Like this. Now, what is the next thing that we need to do here? Okay. Now, we have this difference equation. You can write it in many ways, but it is this. It is this. Okay. Now, with that said, what do we do next? What do we do next? What we do next is we find the approximations. So we can use it in this form. So in other words, we know W0. Okay, let me write from the first question. Can write in terms of Y and then translate W's. We know that I can write, okay, just the differential equation first. dy dx is the question equals y squared, but the initial value is this. This is the question. So which means W0 is 1. So we have W0, then we must get W1, W2, and so on. Okay. So now we must get W1. So W1 occurs when I is 0, so which means that you shall have 0, 0.1. Okay, can cut out some of the work here and make it easier. So this is that 0.10 cubed, okay, and then 0.1 squared W0 to the 4th power, 0.1 cubed W0 to the 5th power. What have we done? We just replaced every I by 0, and then we are able to obtain W1. Okay, sorry. Now, if this is the case, then we can be able to get W1 by substitution because we know W0 here. We know W0. So which means that W1 is 1 plus 0.1 into W0 is 1 squared, 1 cubed, squared, 1 cubed, 1. Right. Now, W1 is, okay, can I use a calculator quickly, which is 1 plus 0.1. And you have 1 squared. And then 0.1 times 1 cubed, just 0.1. Just write 0.1 here. And then here, which is 0.1 squared times 1, 0.1 squared. And then after 0.1 squared, we have 0.1 cubed. Like this. Okay. So this is W1. We just calculate this one. Okay. Perhaps we can just use a calculator here to do it, so that we have some activity on the screen and see what we get together. I can use my own portable calculator, but let me use the calculator here. All right, if I use this calculator, so we're here. Right, so now what is this? So we have a 1 plus 0.1 into 1, just 1 squared, which is 1 plus 0.1 plus 0.1 squared plus 0.1 cubed. Close. Right. It appears it's 1 point quadruple 1. So it appears that the answer we're getting is that W1 is 1 point quadruple 1, like so. Okay, now this is the answer we're getting, but this is in the spirit of the computations because the W0 is 1 from dy dx. We're trying to interpret this. So, but this is the question by and large. We have the differential equation this, and we have that is 4th order, and we have that this is 1. So W0 is 1. But what I'm trying to say is it's computed at the variable, so x0 is 0. X0 is 0. So, and then y0 is 1. Y0 is W0 in the notation of the textbook. So Right. Now, what is W1? Well, W1 means that we're computing that at one step ahead. Right, we're computing it at one step ahead. So we're computing it at, it's like finding y at one step. But remember that Wx, which is age in the question, is 0.1. And so it means that this one is at 0.1. Is y at 0.1, which is approximately 1 point this. Okay, obviously we can write it in the notation here of the book as well, that this y at 0.1, which is just one step h, is approximately the first w in the difference equation, and this first w is 1 point this. Okay. This is very important for us because the examiner said in the question I'm having here in November, they said y at 0.1 is what? And y at 0.2 is what using Taylor. So obviously, because now we found 0.1, but now we are looking at the h. So h now is 0.1, and then the next one you add 0.1 to this one to 0.1, and you get 0.2. So we must do W2 now. That's my point. So, but to do W2, we need to just write the difference equation we got and then use it to do W2. Okay. So we have Wi plus 1, Wi. Uh-huh. Wi plus 0.1. 'Wi squared. Zero 0.1 Wi cubed. 0.1 squared Wi to the fourth power. What did we have? To the fourth power. Okay, and then I forget sometimes. Okay, yeah. So 0.1 cubed Wi to the fifth power. 0.1 cubed Wi to the fifth power. So now we're looking for W2 because it's at the next H, 0.2. So W2 is going to occur when I is 1 here. 1 squared cubed 1/4. Oops. Third 1/5. Right, so this is what we're getting. Let's check if we did not miss some squares or anything. Right, it looks okay. So now we just need to put the W1, but W1 becomes the preceding one. So we must just use the preceding one, and the preceding one, W1, is 1 point quadruple 1. So which means it's 1 point quadruple 1 like this. Okay. Okay. Where am I now? Is the square here? Then cube. Then, okay, this is, yeah, this is square here to the fourth power. And then there's a cube. To the fifth power. Okay, then we just need to do this one. Why are we doing this one, the W2? Because this W2 now is at the next H step, meaning that the answer we're going to get here is going to be Y at 0.2, because the other one is 0.1. But now this one is, okay, if we use Y, you see the reason why the book is using the W than just Y here, because the book understands that the guy who wrote the book understands that Y is the accurate, is the exact solution. But now W, these are just approximate solutions, so that if you write the Y would mean we're referring to the exact solution to the problem, but the exact solution becomes, therefore, it's approximately this, whatever we're going to get here, so that the answer we're going to get here is not really Y, but it's some approximate value, and that's why the book, the guy who wrote the book was using W. I mean, that is the essence, because from time to time, I was thinking, why are the W's? But yeah, because the guy understands that we are dealing with approximations here. These things we're dealing with, the W's, are not really Y's themselves. However, I mean, in the material, like in the exam, it's popular to use Y than just W, so you just have that choice. Okay, let's just do this here, because I did not do it during my own leisure. So it's 1.1 this plus 0.1 into 1 point this, you square it, plus 0.1 times 1 point quadruple 1, and then you can cube it, plus, and then here you have 0.1, which is square, and then but the square is multiplied by fourth power, 1 point, quadruple 1, you raise it to the fourth power, and then here, then we have plus 0.1 cubed. Mm, okay. Then after typing so many things, you always wonder if you started correctly. Just 1 sec. Right, we started correctly, and the 0.1 looks all well. Okay, so it appears that the answer to this, therefore, is 1.1. So it's exactly the answer, but I mean, it's the approximate value. So it's 1.299. Right, so, okay, just 1 sec. I'm just writing that one now. Okay, but if I write it down, then normally so I'm writing it down. So you have 1 point. 1.24 99 6477. And this is the answer. Okay, this is the approximate value of W2 of Y at 0.2. So, I mean, with the point we're raising here, note that. Let me just say hence, please. It's enough. Hence, Y at 0.1. One point 0.2. Nine nine 6477. Okay, these are the answers to the problem because they said that we're to solve, since we had to solve, I'm just being brief here, dy dx, which is y squared at y 0 equals 1, or yeah, at x 0.1 and x 0.2, goodness me, with delta x equals 1. So it's something that you need to sort of consider as a matter of fact. So you have that. Okay. Right. Simultaneously, I want us to look at further problems on this. Just a second. I'm gonna pop in another question now that we need to discuss. Right, so that we learn more. In particular, that relates to exam questions on these kinds of things. Right. See what else we can have here. Right. Right. Let me see what else we can use, we can do. Right, we're going to do some questions now. I need to load. Looking at my question bank. And see what we can do to load another question. Okay, I want us to spend some time on Rungekuta as well. So let's discuss Rungekuta. Right. Rungekuta is extremely important. But now there's Rungekuta of different orders, order 2, order 1, and so on and so forth. Being the most popular for this course, Rungekuta of even order, but we have said that, so yeah, we spoke about Rungekuta of order 2 because we said that the modified Euler, yeah, Rungekuta is fine. So I'm going to just write that statement again because I want to speak about fourth order today, right now. The modified Euler, first things first, because we've been speaking much about that. The modified Euler's method is Runge-Kutta of order 2. Okay, we are here still. Fourth order. Okay, but modified Euler is Runge-Kutta of order 2. What is the modified Euler? Obviously, we're very exhausted with that because we have been stating it a billion ways, but for the sake of our presentation now and discussion on the Runge-Kutta, let's just state that because now I want to draw just a comparison between the difference between this Runge-Kutta and the modified Euler. Right, we remember that it's this, okay, in terms of, we studied it in so many ways, but key to that is that okay, the form I have stated it. Yeah, I want to use the form I stated recently, not the former, but the most recent in two-equation form. Right, because we have stated in two-equation form. Okay, the modified Euler can be stated in many ways. For example, first you can state the Euler and say W0 is alpha, and state this one for the Euler. And this one is what we call the predictor, which is HF of TIWI. And then now we have the other one for the corrector. Right, so, and I want to just bring your attention to this. Okay. Would remember, therefore, that if you are speaking about the corrector is WI, you have H over 2, then you put the, just take the average, you have this here, and you'd have this one here. And obviously now we write this in terms of the TI together with the okay, TI plus 1. And then we write here, can write here W, yeah, WI plus 1. So it can be written like this. But obviously with the understanding that this WI plus 1 is this. Okay, many times we called these the predictor. You can put a power and put it down. Correct this one. Okay, so we just continue with that. I'm just writing this down because I want to advance to something else. Okay, so this is the predictor component. So sometimes we will write these here, this long thing here. Okay, now this is the modified Euler. Just can read in billions of ways, but yeah, that's what it is. Now I want us to consider this modified Euler and say modified Euler is Runge-Kutta of order 2. Okay, because there's Runge-Kutta of order 4, order 3, and so on. Now, what is this? Okay, now I want us to say if, or if you let, yeah, if you let K1 be this thing here, just this one with H, So it becomes H. And K2 be the other one. H of this. Just leave the 2 out of it. Okay, I know I wrote these, but they are in different symbols, but like this. If you let this, then we obtain, right? We obtain the Runge-Kutta relation. So we obtain that Wi plus 1 can be written as Wi plus 1 plus half of K1 plus K2, and this becomes Runge-Kutta. Okay, this is Runge-Kutta of order 2, but it is basically the same as manifold Euler. Right, so is Runge-Kutta of order 2. Okay, I'm going to spend a lot of time on Runge-Kutta tomorrow and other things. Runge-Kutta of order 2, which is the same, as the modified Euler. Modified Euler's method. Like so. I want us to speak of Runge-Kutta of order 4. Because Runge-Kutta of order 2, we've already spoken about it. It's the modified Euler. So in case the question comes in the exam, then we know. But yeah, I'm going to get some questions on Runge-Kutta, a lot of them tomorrow, and our finite difference methods and things. Right, and yeah, there are lots of things we need to speak about. My aim is by the time we get closer to exam, once have written the solutions to the exams in detail. Right, so the Runge-Kutta order 4, because the paper that's going to come is going to be the same as one of these, I can guarantee, because this one was just May, June 2020, the one that came in November. So the one that's coming is going to be one of these. So if let's do 2020, 2021, 2022, 2023, then there's no way that it's going to be different. Just mentioning that. Okay, now, but we'll discuss the full memos with the formulas. That is my aim. When I have discussions of the full memo. Yeah, but in brief to cut out time and things to make sure at least we can see if we can finish a paper, the discussion, something like that. Yeah, okay. I'm gonna try that. We can split into 2 discussions. We'll see. But yeah, if we can finish a paper in 2 hours, that'll be good enough. Try to be faster. Okay, right. So the Runge-Kutta order 4. What is the formula for Runge-Kutta of order 4? Okay, it can be written in many ways, but in terms of the textbook notation, W0 is alpha, K1 is H, F, T, I, W, I, K2 is HF, okay. K1, okay. K3 is HF, TI plus H, WI plus half K2. HF WI plus K3 1 out of 6 K1 plus K2. Oh, 2K2. All right, I want us to just take a look at these Runge-Kutta order 4. We're going to use it to solve some problems. K2 plus 2K3 plus K4. Okay, now this is Runge-Kutta order 4. Okay, so is W0 equals alpha, K1 is HF like that, and K2 is exactly as given there. But what are we seeing here? Okay, the first component of the F, like in the K1 notation, then we can be able to generalize this and also look at what happens in subsequent things. Okay, what do we have here? Okay, because you can see that this is Ti, then it's Ti plus the H over 2. That is Ti plus H over 2. Then the fourth one is Ti plus 1. And then this one here is Wi plus half K1. So in the second component, you have half K1. And then here you have half K2. Okay. Then here you put K3. And this is the Runge-Kutta order 4. Okay, let's see what do we do with this here. Let's see what do we do with these here. So for the purposes, I'm gonna state a problem that we're gonna spend time on tomorrow. You can even start it today. Here's an example on Runge-Kutta. Okay, because we're gonna do exam questions on Runge-Kutta. Very important for this course. So understanding it will bring some results. Right. The question says, use. You can try to do it in a shorter way, like if you tabulate everything, right? Use the Runge-Kutta of order 4 with H is 0.2, N is 10, and okay, in the notation of the textbook, sometimes they write Ti as this. That normally happens when, okay, you'll understand when you look at the initial value. When the initial value has a 0 component, to obtain approximations to the solution. Of the initial value problem. y primed. Plus 1. Okay, now we have this problem. Use the recruiter of order 4 with h equals 0.2, n equals 10, ti equals 0.2i to obtain approximations to the solution of the initial value problem. Right. This is what I'm going to do tomorrow. It's going to be long. So we're going to spend some time on it tomorrow. And yeah, it's going to be an interesting one. But my point is that tomorrow we're going to be looking at Runge-Kutta and other parts of the thing of the course. So I'm sure that it's going to be very, very useful for us to understand this. But also